Developers who cut their teeth on Java or Solidity ask, where are the classes? In Move, modules hold behavior while structs hold data, but every OOP objective, hiding internals, reusing code, modeling life cycles, still applies. By dropping inheritance, Move avoids fragile base class hierarchies and replaces them with composition plus type-level guarantees supplied by abilities. You'll see the patterns you know, but each comes with an audit-friendly twist. Because fields are invisible outside their module, you can refactor without fear of breaking strangers' code. Expose a thin public surface. Tuck validation helpers behind it. When two modules legitimately share state, upgrade logic or cross-package libraries, add a friend declaration. Reviewers instantly know which parts of the codebase can bypass defenses and why. Rather than inherit from a giant base class, Move code embeds smaller structs. A user owns a profile owns an address. Each layer brings its own abilities. Address is plain data, copy plus drop plus store. User may be a resource, key plus store. The compiler prevents cyclic references and the mental model mirrors real-world containment. Polymorphism in Move is static. You write one implementation of box, the compiler spits out concrete versions for every T used. By forcing callers to supply only types with store, you guarantee that the boxed value can live on chain, and you avoid runtime panics when someone tries to stash a non-storable phantom. Some workflows should be impossible by construction. Think KYC pending versus active trading. The type state idiom encodes the state in the type system. Users start with account. Only the activate function consumes that value and returns account. Any attempted deposit into a pending account fails to compile. Phantom parameters keep the enum tag in the type rather than on-chain data, so you don't pay a single byte of gas for the guarantee. In an OO language, you might implement an interface iMinter. In Move, you mint a mint cap resource. Possessing that value signals the same intent, but the enforcement happens in the type system, not at runtime checks scattered around the code. Because caps are resources, they inherit all the ownership semantics. They can be delegated, escrowed, even sold, and the compiler still ensures they never multiply. Move events deliver the observer pattern with one line of code. Your module emits transfer event. Wallets, dashboards, alert bots consume it in real time without forcing your contract to know a single endpoint. Events are never stored on chain, only in the validator's event DB, so they cost a tiny compute fee and no long-term storage deposit. This one file demonstrates nearly every pattern we discussed. Account is generic over a phantom state type, pending, active, or frozen. Each transition function consumes the old value and produces the new one, so the compiler enforces the workflow. Try call and withdraw on a frozen account. Build fails. No runtime flags, no if status equals branches, just compile time certainty. Here we embed address inside profile, then embed profile inside user. A helper like city simply drills through the chain. No inheritance required, no duplicated getters. If you later compress address into geohashes, only this module needs touch-ups.